Welcome back to Business Mathematics 1. I'm Eric from Mathematics Study Program, Faculty of Mathematics and Natural Sciences, ITB. So we are still talking about Introduction to Integral, which has special focus on application on area between two curves. Let's start. The first problem is the net excess profit. So suppose that T years from now, two investments will be generating profit, that is P1T and P2T, respectively. Their respective rates of profitability are P1 prime and P2 prime. It is expected that P2 prime is greater or equal to P1 prime for the next n years. That is over the time interval 0 to n. This is capital N. Okay. The excess profit of plan 2 over plan 1 at time t this one, 0 to capital N, is given by ET, that is P2T minus P1T for at time t. But for the net excess profit on time interval 0 to n, it is given by En minus E0. So the net excess profit can be calculated as En minus E0. But we can use the first fundamental theorem of calculus to have this one. So E prime t dt from 0 to n is just En minus E0, isn't it? And what about this one? E prime t is just P2 prime minus P1 prime. Okay, so the area between P2 prime and P1 prime from interval 0 until n, if P2 prime is higher than P1 prime, so we have the net excess profit of P2 investment compared with P1 investment. So let's look at an example. Okay, this is P2, P1, okay, 0, 0 from n, so we are calculating this. Okay, and it is given by this. Okay, so this is the net excess profit. So it is given by a rate of profitability of first investment and second investment. Is first investment is 50 plus t squared, and second investment is this. Don't forget $100 per year, P2 prime, the rate of change of profit with respect to time. So $100 per year. For how many years does the rate of profitability of the second investment exceed that of the first? So what we want to find is what time t when does P2 prime exceed P1 prime? Okay, and the second question is compute the net excess profit for the time period determined in the first part. Interpret the net excess profit as an area. Okay, we want to find this. We can just substitute this. Okay, and I found this. I can simplify into this. So I can draw the sign diagram here. Okay, so you can check this. The sign should be plus, minus, plus. Okay, and so the rate of profitability of the second investment exceed that of the first from year minus 10 into 15. But T should be positive, so the rate of profitability of the second investment exceeds that of the first investment from time 0, the beginning, to 15 years. Don't forget T should be positive. Okay, so the net excess profit is given by this. Okay, it is given by this. I can simplify this. I can find this, and the net excess profit is given by this $100. Okay, interpret the net excess profit as an area. So the net excess profit is the area between interval 0 and 15 of the graph P2 prime t between area between P2 prime t and P1 prime t from interval 0 to 15. Okay, so this is the first application. The second application is the Lorentz curve. Lorentz curve is used to measure the percentage of a society's wealth that is possessed by a given percentage of its people. The Lorentz curve for a particular society's economy is the graph of the function Lx, which denotes the fraction of total annual national income earned by the lowest paid 100x% of the wage earner in the society, for x is from 0 to 1. Okay, yeah? So, for instance, if the lowest paid 30%, don't forget, okay, don't forget if the lowest paid 30%, x equals 0.3, okay, this is 0.3, x equals 0.3, that is 30% of all wage earner receive 23% of the society total income, then L 0,3 is 0,23. Okay, yeah? And if a country has Lorentz curve such that L 0.9 is 0.01, it should be dot, it should not be a comma here, yeah. L 0.9 is 0.01, so it means the lowest paid 90% of all wage earner receive just 1% of the country's total income. What do you think of this country? So the 10% own the 90% of the income. So I think in this country, the wealth isn't distributed equally. Okay, yeah? So what about if a society which consists of teachers has Lorentz curve that L 0,5 equals 0,48? This means the lowest paid 100 times 0,5%, that is 50% of all wage earner in this society, the lowest paid, receive 48% of the total income of society total income. Okay, so what do you think of this society economy? Yeah, it's so, yeah, it's equal. So let's look at the example of Lorentz curve. So this is the fraction of wage earner. This is a complete equality. So if you have this kind of Lx and this one, this is what we usually like L 0.9 equals 0.01. So 90% of the lowest paid wage earner receive just 1% of all total wealth of the country, So the 10% of the country have 90% of the total wealth of the country. So the country is not so good. So if you have more flat here and sharp here, it means that the country is not too good. But if it comes closer and closer to the equality, it means that the wealth of the nation is equally distributed. So if you have the nation that is equally distributed, you have this one, the Lorentz curve is given y equals x. If you are not equally distributed, you have a sharp edge here. So that is the not so good country, yeah, because the wealth is not distributed equally between all the page between all the society. So the Gini index is defined as the area of R1 divided by R2 in this one. So this is R1. So this is y equals x. So this y equals Lx is this one. Okay. So R1 divided by R2 is what we usually call the Gini index. So when does the Gini index will give you 1, total 1? So R1 should be the same as this. So it means that Lx should be this. So if your Gini index is 1, so the distribution of wealth in that society is very, very bad. Okay, but if the Gini index closer and closer to 0, so R1 is closer to equality, So closer to equality, so it will give you 0. So when the Gini index is getting you closer to 0, it means you have an equality. Okay, so the distribution of wealth in that society is okay, it is equally distributed. Okay, so if the Gini index is higher, it is not so good. Okay, so this one we have, so in this one we have Denmark is which has the lowest Gini index. It means the wealth is distributed almost equal. And we have Brazil. In Brazil is not so good because the Gini index is 0.6. Okay, 0.6. Remember, so when Gini index gets to 1, it means that the distribution of wealth is not distributed equally. Okay, so this in this one, Brazil is bad, but Denmark is better than Brazil. Okay, so the Lorentz curve of some society, let's say that Lorentz curve of some society is given by Lx equals x squared. Find the Gini index of that society. Okay, so the Gini index is R1 divided by R2. What is R1? R1 is, don't forget in this. Okay, so when y equals x squared, the R1 is x minus x squared. Okay, x minus x squared. So R1 should be, this is x squared. I think this is wrong, yeah. So R1 should be x minus x squared instead of x squared, yeah. So this is wrong. It should be x minus x squared divided by R2. R2 is this one, yeah. A half times 1 times 1, that is a half. So I have, this is wrong, yeah. So it should be x minus x squared dx. So I have this x minus lx. So R1 should be x minus lx. So this is wrong, but you know how to find the Gini index, yeah? Okay, and this is the last application of the counting the area between two curves, that is the average value of a function. So if I have f is continuous function at interval a and b, the average value of f at ab is given by this one. 1 over b minus a integral ab fx dx. So this is the area between curve fx and 0. Okay, this is the area below the fx and upper the x-axis, and you divide it by b minus a. So this is the average of the value f from a to b. Average value of f from interval b until a. Okay, so suppose that 3 years from now an investment is generating profit pt equals t squared $100 at years 1 to 3. Find the average profit during this year. So the average profit is given by 1 over 3 minus 1 integral 1 over t squared dt. I can simplify this and to this, and I have $4,300. So $430 is the average profit during these 2 years, from years 1 until 3. Okay, later we will discuss again about application of integral. Okay, thank you very much.